This is a brushless motor, and welcome to Brushless Motor Explained. A brushless motor is an electric motor that operates without mechanical brushes, using electronic commutation to control the current flow in the windings, resulting in higher efficiency, reliability, and longevity. Let's start with a basic circuit. Based on the circuit, by using a right-hand grip rule on the solenoid, when we apply the appropriate current, the coil will generate a magnetic field that will attract the rotor's permanent magnet. The magnet will turn to the position based on the direction of the current flow and the resulting magnetic field. So as you can see, when we apply positive and negative charge to the terminals, which are the coils, the rotor magnet will align itself due to the attraction. By continuously interchanging the charges on the terminals, the rotor magnet will constantly chase the changing magnetic fields and rotate, thereby generating motion. So this is the interior of a brushless motor I will be using to demonstrate today. There are 14 coils on it. These are the stators which generate magnetic fields by supplying current. This here is the rotor magnet which interacts with the magnetic field to produce rotational motion. And this is the ESC, known as the electronic speed controller. It is a microcontroller used to control the brushless motor. It uses MOSFETs to continuously switch on and off the terminals, thereby regulating the current flow to the motor and controlling its speed and direction. By connecting the ESC to my laptop and the brushless motor, I can control the motor at any desired speed with the help of appropriate software. Now let's talk about the theory behind this. What is the relationship between the current and magnetic strength? As Ampere's law describes, the magnetic field generated by a coil is proportional to the current flowing through it. Therefore, the higher the current, the higher the magnetic strength, and thus more torque is produced in the brushless motor. So let's prove it by demonstrating. This is the software I'm using to control the brushless motor. And here's the graph that's showing motor's performance. The green line represents the duty cycle, which is the speed at which the MOSFETs are switching on and off, providing the power to the motor. The red line represents the current in the motor. As you can see, when I grip the motor while it is rotating, more current is applied to the motor to overcome my resistance by generating higher magnetic strength. When I release it, the current returns to normal. Basically, that's all you need to know about the brushless motors. Thank you and peace out.